All right, we're going to be talking about word problems that involve totals or sums. You're often told the sum of two numbers is 240 and you're supposed to separate it into two parts. Or you're told to separate 144 into two parts. You might be told that the sum of two numbers is 25. When you get that, your label box is nice and easy. You're still only going to use one variable, and you're going to use what we call the total labeling technique. And let's think about if you had this piece of wood right here, and it is 32 inches long. So if you take your saw and you cut through it, here's your saw with the handle, okay, and you cut through that, if this side is 3 inches long, you know for a fact that this side is 29 inches long. How did you get 29? Well, what you did in your head really was a subtraction problem. So if this side is 14 inches long, then what is this side on the left? That's 18 inches long. Again, you did a subtraction problem. You did 32 minus 18. So what that means is if one side is x, then the other side is going to be the total minus x, and you should write that down. Total minus x. And the other variable is going to be x. So in this case, rather than total, it's going to be 32 minus x. Okay, so let's practice that. So if the sum of two numbers is 240, the smaller number is represented by x. So how do you represent the larger? 240 minus x. A man spent $365 on a suit and a coat. If he spent y dollars on the coat, represent the amount the man spent on the suit. Okay, so suit plus coat equals 365. The coat was y, so the suit has to be the remainder after you take away y from 365. So again, notice total minus the part. All right, a man gave a total of $200 to his son and daughter. If the boy received M, represent the amount the daughter received. So that would be the total minus M. Notice all of these are subtraction, so the order matters. It's got to be total coming first. All right, so let's try some problems. My recommendation to you is use your total labeling technique for your label box and use the other more complicated information to create your equation. So separate 160 into two parts. So x is going to be one part, and what would be my other part? The other part is going to be, I need to use x. Okay, good. That would be, wait, x minus 160? No, 160 minus x. Remember, total minus the part. Okay, I'm just going to decide, it's going to talk about the larger will be 3 times the smaller. You know what's cool about word problems? You get to just decide. I'm declaring the larger is going to be x. Why? Because I said so. And you know what? It's going to work out because I'm in charge. It's a weird thing about word problems. When you're creating a label box and defining variables, you get to be the boss. All right, so the larger will be. So x will be equals, that's a verb, so will be 3 times the smaller. So 3 times whatever the smaller is. So how do I represent the smaller? Oh, here's the smaller. Okay, so put in 160 minus x. All right, so let's simplify. All right, so find the numbers. So the numbers are 120 and how do I figure out the other number? Well, x is 120, so the other number is 160 minus 120, so that would be 40. Okay, now I need to check it. So is 120 plus 40? Yeah, that equals 160, so that's good. And then is the larger 3 times 40? Yeah, cool. Sweet, so it checks. All right, so separate 144 into two parts. All right, that will be another problem. Let's see. Let's practice one of these down here. Okay, separate 65 into 2 parts. All right, let's try this. It's a little bit different. It's not exactly the total labeling techniques, but it's talking about the larger and the smaller. So let's say x is the larger. Well, I don't know yet. We know the larger is 20 more than the smaller. So I do want to make, no, I want to make x the smaller, because then if I make the larger, then I'll be able to add. So how do I get to the larger if it's 20 more? So I'd add 20. So rather, I could certainly have done x is the larger, and then the smaller would have just been x minus 20. That's totally fine. All right, now 4 times the larger. So 4 times the larger is equals. Notice, look for that verb and make it your equals. 70 more, so 70 more than 5 times whatever my smaller is. All right, so what's my smaller? Smaller is x, 5 times the smaller. All right, 4 times the larger, so 4 times the larger. Okay, the larger is x plus 20. Cool. I'm using my grouping symbols just to make sure I stay safe. All right, go ahead, pause this while we work it out on our papers. Cool, you subtracted 4x, subtract 70, so x is 10. 10 and 30 are the numbers. Let's check it. Okay, the larger of two numbers is 20 more. Cool, yeah, because 20 plus 10 is 30. All right, 4 times the larger, so 4 times 30 is 120. Is that 70 more than 50? Because 5 times is smaller. Yeah, okay, cool. Great. So these problems take a while to digest. But this is a really tricky but important part of algebra because it's taking your written word, your world, and it's turning into math. Now, these don't seem like very important problems because they're just about a bunch of random numbers, but trust me, when things get more complicated, like the percent of taxes or the rate at which you should charge somebody or a nanny working overtime or, you know, the number of pounds of cheese you need to run your bakery, then it matters.